Okay, so here we go with the second half of lesson 1 on chapter 2.1. This is the modulus functions. Example 3, sketch the graph y equals 3x minus 2. Or the modulus of 3x minus 2 rather. So first, sketch y equals 3x minus 2. So, just depending on what you remember, we can put in x and y values. There are other ways of doing this. We could take x as 0 and we get y as minus 2. And if we take another value of x or put in a value of y, often they're the two we just put in. Y is 0. If y is 0, then x equals 2/3. Add the 2 across, divide by 3. So you've got 2 points. As soon as you've got 2 points, you can draw a straight line graph. The other way of doing this would be to say 3 is the gradient and negative 2 is the y-intercept. So it just depends what you remember. You can either go back, find 2 points, draw your line through the 2 points, or you can use the fact that you know the gradient and the y-intercept. So let's now sketch the graph. I'm going to use the gradient and y-intercept version. So here's our x-axis, here's our y-axis. Please use a ruler when you do it. And we've got gradient 3, so that's fairly steep, and goes down and crosses at negative 2. So that's the line y equals 3x minus 2. But that's not the answer, because we want the modulus. Now the modulus says the outputs, the modulus of a function, says outputs are positive. So instead of getting negative 2 as our y-intercept down here, we're going to get positive 2 as our y-intercept. So this whole section of the line here is going to get reflected. So for that reason, when I do it, I tend to draw this part in. Anything that goes below the line, below the x-axis, I draw in as a dashed line, and then I reflect. So I've got a reflection of the negative part of the graph. So we reflect in the x-axis anything which has a negative output. That's y value. Okay. Now hopefully we remember from GCSE, when you reflecting in the y-axis, so if you go from f of x is mapped onto minus f of x, reflects in x-axis. The negative sign is outside the function, so the points move in the y direction. Out side function. Therefore, points move in y direction. So -2 moved up to +2, etc. here. Okay, so that means the equation of this line up here, the y values are now the negative of the other side. Yeah, so it's the negative of 3x minus 2, because this was 3x minus 2 over here. Well, we can tidy that up, so we get y is minus 3x plus 2 for that bit of the line. I hope that makes sense. Okay, let's move down. Example 4. Solve the equation, the modulus of 2x minus 1 equals 5. Now, a good habit to get into here is to sketch first. So we're going to split this. So we're going to sketch y equals 2x minus 1 as one function, and y equals 5 as our second function. Okay, and we've done stuff like that at GCSE. So we've got to sketch those two graphs. Well, let's start with the 2x minus 1. Minus 1 will be down here somewhere. 2x is fairly steep. Dash when it becomes negative, and then reflect it. So the minus 1 will move to become plus 1. Yeah, and all the other points are doing the same thing. They're being reflected, reflect in x axis, all the negative values. Okay, so now let's find the equation of these two lines. So y is equal to 2x minus 1, because where the graph is positive, the outputs of the magnitude of 2x minus 1 is the same as 2x minus 1. And over here, y is equal to the negative of 2x minus 1, which is better written as minus 2x plus 1. Okay, so we've now sketched our first line. Now we want to sketch our second line. Y equals 5. So y is equal to 5 is going to be a straight line across here. And we can see then that to our original equation, we've got two solutions. One point over here where 2x minus 1 is equal to 5, and one point over here where minus 2x plus 1 is equal to 5. And we've got to find those two x values. Yeah, so what we're looking for is where those values, the x values, the x values, we could call this one x1 and this one x2, but it's the x values of where those line cross that we're looking for. So, x1. That solution is where 2x minus 1 is equal to 5. So 2x is equal to 6, x is equal to 3. For x2, we've got minus 2x plus 1 as the equation of the sort of sloping line, if you like, again is equal to 5. So solve it in the usual way, make the coefficient of x positive, or move the lowest number of x's. So we get 1, 1 is equal to 5 plus 2x minus 4 equals 2x. So x equals negative 2. And that fits with our diagram. x1 is on the positive side here, and x2 is on the negative side. So we're happy with those as our answers. Okay, I hope that is clear.